Good morning. We have an exciting one for you today. We started this 12-day event 12 days ago with the launch of O1, our first reasoning model. It's been amazing to see what people are doing with that and very gratifying to hear how much people like it. We view this as sort of the beginning of the next phase of AI, where you can use these models to do increasingly complex tasks that require a lot of reasoning. And so for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but really good at performance and cost. So
OpenAI's O3 model shocks the world. Has AGI finally arrived? This revolutionary AI has surpassed human intelligence on key benchmarks, shattered coding and math records, and left experts stunned. Are we witnessing the birth of true artificial general intelligence, or is this just the beginning of something even bigger? On December 20th, 2024, the last day of their 12 Days of OpenAI event, the company introduced O3, the successor to their O1 model, and they didn't just stop there. They also revealed a 3 Mini, a lighter version of this powerhouse. Now, you might be wondering, what happened to O2? Well, it seems OpenAI decided to skip that name, possibly due to a certain British telecom company. But let's not get hung up on names. It's what these models can do that's truly amazing. So what's the big deal about O3? It all comes down to its performance on some seriously tough benchmarks. Let's break it down. First up, we've got the ARC-AGI benchmark. This isn't your average test. It's designed to measure an AI's ability to reason and adapt to new situations, much like a human would. Francois Chollet, an engineer at Google and the creator of the ARC challenge, explains it like this. ARC is intended as a kind of IQ test for machine intelligence, and what makes it different from most benchmarks out there is that it's designed to be resistant to memorization.
Sure. So ARC is intended as a kind of IQ test for machine intelligence. And what makes it different from most LLM benchmarks out there is that it's designed to be resistant to memorization. So if you look at the way LLMs work, they're basically this big interpolative memory. And the way you scale up their capabilities is by trying to cram as much knowledge and patterns as possible into them. And by contrast, ARC does not require a lot of knowledge at all. It's designed to only require what's known as core knowledge, which is basic knowledge about things like elementary physics, objectness, counting, that sort of thing. The sort of knowledge that any 4-year-old or 5-year-old possesses, right? But what's interesting is that each puzzle in ARC is novel, is something that you've probably not encountered before, even if you've memorized the entire internet.
Here's where things get interesting. O3 scored a whopping 87.5% on this test. Why is that significant? Well, the average human score is 85%. That's right. O3 just outperformed humans on a test of general intelligence.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC-AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah.
To put this in perspective, let's look at the history of AI performance on this benchmark. Just 4 years ago, in 2020, AI models were scoring a big fat 0. Earlier in 2024, the best models were hitting around 5%. And now, in a matter of months, O3 has shattered all expectations. This isn't just progress, it's a quantum leap. Greg Kamrad, president of the ARC Prize Foundation, put it this way.
Be memorized. That's the whole point here. Now, ARC-AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC-AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC-AGI Pub. So congratulations to that.
Thank you so much, yeah.
But wait, there's more. O3 didn't just excel in one area, it crushed it across multiple domains. In coding, O3 achieved 71.7% accuracy on the SWE bench, a real-world coding task benchmark. That's a 20% improvement over its predecessor, O1. On Codeforces, a competitive coding platform, O3 reached an ELO rating of 2727. To put that in context, O1's rating was 1891. We're talking about performance at the level of top-tier human programmers.
Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweBench Verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this context coding site called Codeforces about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 2727 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2500.
That's tough.
When it comes to math, O3 is giving even the brightest minds a run for their money. On the AIME 2024 competition math benchmark, it scored 96.7% accuracy. Its predecessor, O1, managed 83.3%. On the Epic AI Frontier Math benchmark, which consists of problems that would make professional mathematicians sweat, O3 achieved over 25% accuracy. That might not sound impressive until you realize it's a tenfold improvement over previous models.
So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AIME.
What's your best AIME score?
I did get a perfect score once on this, so I'm safe. But yeah, really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark.
And if that wasn't enough, O3 tackled PhD-level science questions on the GPQA Diamond benchmark with 87.7% accuracy. We're talking about questions that would stump most experts in their fields.
There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD-level science questions. Here we get another state-of-the-art number, 87.7%. which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie.
Now, you might be wondering, how on earth is a 3 pulling this off? The secret sauce lies in its technical innovations. OpenAI has employed some clever tricks to reinforcement learning for reasoning. This allows O3 to learn from its own problem-solving attempts and improve over time. Chain of thought prompting. O3 breaks down complex problems into smaller, more manageable steps, much like a human would. This technique enhances both problem-solving capabilities and transparency. Adaptive Thinking Time API. This feature lets users toggle between different reasoning modes, low, medium, and high, to balance speed and accuracy. It's a game changer for tasks with varying complexity. Natural language program synthesis. O3 can generate and execute programs in real time to solve novel problems. This is a significant departure from traditional language models. Test time adaptation and search capabilities. This allows O3 to explore multiple solution paths, adapting its approach based on the specific problem at hand. It's like having a super-powered problem-solving engine. But here's the million-dollar question. Does this mean we've achieved AGI? Well, that's where things get a bit murky. Some experts, like Francois Chollet, are impressed but cautious. Chollet stated, "While the new model is very impressive and represents a big milestone on the way towards AGI, I don't believe this is AGI. There's still a fair number of very easy ARC challenge tasks that O3 can't solve." He also added an interesting perspective on what true AGI might look like. You'll know AGI is here when the exercise of creating tasks that are easy for regular humans but hard for AI becomes simply impossible. Others point out that while O3's performance is remarkable, it still lacks some fundamental aspects of human cognition. As Thomas Diederich from Oregon State University notes, by this measure, the commercial AI systems are missing episodic memory, planning, logical reasoning, and most importantly, metacognition. So, what are the implications of O3? They're potentially huge. We could see revolutionary applications across various sectors, from healthcare to finance to scientific research. The model's ability to handle complex mathematical problems and generate sophisticated algorithms could accelerate breakthroughs in fields like drug discovery, climate modeling, and quantum computing. But it also raises serious questions about job displacement, economic restructuring, and the ethical use of such powerful technology. As O3 demonstrates near-human or superhuman performance in areas like coding and mathematical problem-solving, we might see significant disruptions in high-skill industries. This could lead to a reshaping of the job market and educational priorities. And let's not forget about the challenges. O3 isn't perfect, far from it. Its computational costs are astronomical, ranging from $20 to $2,000 per task. It can take up to 13 minutes to process a single task. And despite its prowess in complex problem solving, it can still make simple errors that a human child wouldn't. This brings us to an interesting debate. Is O3 truly reasoning, or is it just really good at searching through possible solutions? Some argue that its approach is more brute force than true intelligence. One expert stated, "Instead of the model figuring out abstractions and world models, it is now relying on creating a large number of candidate solutions and trying every one of them." Dr. Jim Fan, an AI researcher, provides an interesting perspective on O3's capabilities. Thoughts about O3? I'll skip the obvious part. Extraordinary reasoning, frontier math is insanely hard, etc. I to 3 hink the essence of O3 is about relaxing a single-point RL superintelligence to cover more points in the space of useful problems. He goes on to explain, O3 is a superintelligence when operating in these domains. The key difference is that AlphaGo uses RL to optimize for a simple, almost trivially defined reward function. Winning the game gives 1, losing gives 0. Learning reward, functions for sophisticated math, and software engineering are much harder. This highlights the complexity of O3's achievements and the challenges it overcame. Of course, OpenAI isn't the only player in this game. Google is hot on their heels with Gemini 2.0, which CEO Sundar Pichai describes as the most thoughtful model they've developed. Anthropic has big plans for 2025, aiming to push the AI frontier even further. We're in the midst of an AI arms race, and the pace is only accelerating. All of this raises urgent questions about policy and regulation. How do we govern something that's advancing faster than our ability to understand it? We need proactive frameworks, global coordination, and serious consideration of the economic and social impacts of AGI. The emergence of O3-level AI capabilities demands immediate regulatory action. Self-governance by AI companies may not be sufficient. There's a need for proactive governance frameworks that can guide AI development before critical thresholds are crossed. These frameworks must balance innovation with safety while remaining flexible enough to adapt to rapidly changing capabilities. Global coordination presents another challenge. AGI development is happening simultaneously across multiple countries and companies, each with different priorities and values. Without coordinated oversight, we risk a race to the bottom in safety standards or regulatory fragmentation that stifles beneficial progress. Moreover, there's an urgent need for economic and social preparation. The arrival of AGI-level systems will transform labor markets, reshape economic power structures, and challenge fundamental social institutions. We need concrete plans for managing this transition. New educational approaches to prepare workers for an AI-driven economy, social safety nets that account for potential job displacement, and mechanisms to ensure the benefits of AI advances are broadly shared. For now, O3 and O3 Mini are only available for safety testing. OpenAI is taking a cautious approach, which is probably wise given the potential power of these models. They're planning a gradual rollout, with public release dates yet to be announced. Let's take a closer look at O3 Mini, the lighter version of the model. According to OpenAI researcher Haran,
I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple days ago,
O3 Mini supports 3 different options: low, medium, and high reasoning effort, allowing users to adjust the model's thinking time based on their specific use case. This flexibility could make O3 Mini a game changer for a wide range of applications, from simple coding tasks to more complex problem-solving scenarios. In terms of performance, O3 Mini is no slouch. On coding benchmarks, it outperforms a 1 Mini and even matches a 1 in some cases. On mathematical tasks, O3 Mini Low achieves comparable performance to O1 Mini, while O3 Mini Medium surpasses O1. But perhaps the most intriguing aspect of O3 and O3 Mini is their potential for self-improvement. During the demonstration, the model was asked to evaluate itself on a difficult dataset. As one of the presenters said,
right, almost like achieving comparable latency with GPT-4o. Where it's under a second, so probably it's like instant response. And O3 Mini Medium is like half the latency of O1.
This hints at the possibility of AI systems that can not only solve problems, but also assess and improve their own performance, a key step towards true artificial general intelligence. The release of O3 has also sparked discussions about the nature of AI progress and our understanding of intelligence. As one analysis points out, the release of O3 challenges our understanding of current AI optimization techniques. It made us question whether all the fine-tuning, DPO alignment, and other optimization processes we perform are only effective for tasks similar to those in the training data distribution. This observation highlights a crucial point. O3's success might be pushing us to rethink our entire approach to AI development. It suggests that the pre-training and fine-tuning phases we consider the foundation of AGI development may be fundamentally limited in their ability to generalize. François Chalet describes O3's process as an intuition-guided test-time search through program space. While this represents a remarkable achievement, enabling the AI to adapt dynamically to arbitrary tasks, it comes at an immense computational cost and exposes the weaknesses of the traditional AI training pipeline. Looking ahead, the upcoming ARC-AGI 2 benchmark in 2025 will likely amplify these challenges, highlighting areas where O3 cannot deduce hidden patterns or solve even simple problems without enormous computational resources. The pattern of underestimation in AI progress is also worth considering. One of the most consistent patterns in artificial intelligence isn't technological, it's psychological. Time and again, experts and observers have underestimated both the pace of progress and the magnitude of breakthroughs. This exponential growth bias makes it difficult for us to grasp the true pace of AI advancement. What seems impossible today could become routine tomorrow. Even current predictions about AGI timelines may be too conservative. The democratization of AI capabilities is another factor to consider. While OpenAI currently leads in demonstrating advanced AI capabilities, history suggests this advantage will be temporary. The fundamental advances that make O3 possible will inevitably spread throughout the AI ecosystem. This democratization creates both opportunities and risks, potentially driving innovation and economic growth across sectors while also making potential misuse harder to control. Sam Altman, CEO of OpenAI, offers an interesting perspective on the evolving definition of AGI.
It used to be a term that people used a lot, and it was this really smart AI that was very far off in the future. As we get closer to it, I think it's become a less useful term. People use it to mean very different things. Some people use it to mean something that's not that different than O1, and some people use it to mean true super intelligence, something smarter than like all of humanity put together. We try now to use these different levels. We have a 5-level framework. We're on level 2 with agents now. Sorry, with reasoning now, rather than the binary of is it AGI or is it not. I think that became too coarse as we get closer. But I will say, by the end,
He adds,
too coarse as we get closer. But I will say, by the end of next year, end of 25, I expect we will have systems that can do truly astonishing cognitive tasks, like where you'll use it and be like, that thing is.
This statement underscores the rapid pace of AI development and the shifting goalposts of what constitutes AGI. China is revolutionizing global industry by mass-producing advanced humanoid robots for warehouses, factories, and stores. With capabilities like carrying heavy loads, navigating autonomously, and responding to human commands, robots like the Walker S Lite and GR1 showcase cutting-edge AI and robotics. Backed by billions in state funding and rapid manufacturing, China aims to dominate this $38 billion market by 2035, challenging U.S. tech leadership. These robots promise to transform industries from 24/7 factory operations to streamlined logistics and futuristic retail experiences. As China surges ahead, the world grapples with the benefits of efficiency and the risks of job displacement. Subscribe to the channel so never miss our future updates. China is the second world's largest market and producer of robots after Japan. This achievement is not merely a recent development, but the result of years of focused effort and investment. The International Federation of Robotics reports that over the past 3 years, China's newly added robot installations have accounted for more than half of the global market. This statistic alone illustrates the scale and speed at which China is embracing robotic technology. The density of robots in China's manufacturing sector provides another striking indicator of this rapid adoption. In just a decade, the number of robots per 10,000 workers has surged from a modest figure to an impressive 470. This 19-fold increase represents a major shift in how Chinese factories operate and compete on the global stage. It's a transformation that has implications beyond China's borders, setting new standards for manufacturing efficiency and productivity worldwide. At the heart of China's robotics revolution is the Ministry of Industry and Information Technology. This government body has laid out a comprehensive roadmap for the development and deployment of humanoid robots. The MIIT's goal is ambitious yet clear: achieve mass production of these advanced robots by 2025. This timeline, a mere 2 years from now, underscores the urgency and determination driving China's robotics initiative. The MIIT's vision for these robots extends beyond simple automation. They are seen as potentially disruptive products, comparable in impact to the introduction of computers, smartphones, and electric vehicles. Each of these technologies fundamentally altered how we live and work, and China believes humanoid robots have the potential to drive a similar transformation across multiple sectors of the global economy. Several key players are spearheading China's charge into humanoid robotics. UBTech Robotics Corporation, based in Shenzhen, has developed the Walker S Lite robot. This advanced humanoid has already been integrated into real-world industrial settings, such as Zeekr's 5G smart factory in Ningbo. The Walker S Lite's capabilities are impressive. It can carry a maximum load of 15 kilograms and has become the first humanoid robot in China to perform the entire process of moving cargo boxes autonomously. This achievement marks a significant milestone in the practical application of humanoid robots in industrial settings. Another notable player in this field is Fourier Intelligence, a Shanghai-based startup. Their GR1 humanoid robot showcases the rapid progress China is making in this domain. Designed to move at 5 kilometers per hour and carry loads of up to 50 kilograms, the GR1 represents a significant leap forward in robot mobility and strength. Fourier Intelligence's ambitious goal to deliver thousands of these robots in 2024 demonstrates the scale at which China is approaching the mass production of humanoid robots. These robots are not merely mechanical marvels, they represent significant advancements in artificial intelligence and sensor technology. They incorporate multi-sensor fusion perception, a sophisticated system that allows for 360-degree environment awareness and semantic recognition. This means the robots can perceive and understand their surroundings in a way that approaches human-level comprehension, allowing them to navigate complex and changing environments with ease. Natural human-machine interaction is another key feature of these advanced robots. They are designed to understand and respond to human gestures and voice commands, making them more intuitive to work with in various settings. This capability is crucial for their integration into environments where they will be working alongside human employees. The technological advancements extend to the core components of these robots as well. Significant improvements have been made in reducers, controllers, and servo systems. These enhancements have resulted in robots with greater precision, efficiency, and safety features. The progress in these areas is what enables the robots to perform complex tasks with a level of dexterity and reliability that was previously unattainable. The potential applications for these humanoid robots are vast and varied. In manufacturing and industrial settings, they can handle repetitive tasks with great consistency, reducing human error and increasing productivity. This could lead to 24/7 operation of factories with minimal human intervention, potentially revolutionizing manufacturing processes and output. In logistics and warehousing, robots like the GR1 can efficiently move and sort packages, streamlining operations in an industry that has seen explosive growth due to e-commerce. The ability of these robots to work tirelessly and accurately could significantly reduce logistics costs and improve delivery times. The retail and customer service sectors are also potential areas for deployment. Humanoid robots could assist customers manage inventory and even provide personalized shopping experiences. This could transform the retail landscape, offering a blend of efficiency and novelty that could attract consumers and redefine the shopping experience. However, the widespread adoption of these robots also raises important questions about potential job displacement. While some jobs may indeed be automated, it's important to note that the robotics industry is expected to create new roles in robot development, maintenance, and supervision. The challenge lies in managing this transition effectively, ensuring that workers are retrained and reskilled to take on these new roles in the evolving job market. China's strategy for domination in the field of humanoid robotics is multifaceted and comprehensive. The government has implemented a series of supportive policies and measures, including a development plan for the robotics industry and a Robot Plus action plan. These initiatives provide a framework for the growth of the robotics sector, aligning government support with industry needs. Substantial investments are being made in research and development to drive innovation in this field. For instance, Beijing launched a $1.4 billion state-backed fund for robotics in January 2024, while Shanghai announced plans to set up a similar fund in July. These financial commitments underscore the seriousness with which China is pursuing its robotics ambitions. One of China's key advantages in this endeavor is its focus on supply chain integration and mass production capabilities. The country's expertise in fast iteration and production, honed through years of manufacturing experience across various industries, is being applied to the robotics sector. This approach is expected to dramatically reduce production costs, making humanoid robots more accessible and commercially viable. The ability to quickly move from prototype to mass production could give China a significant edge in the global robotics market. In response to China's rapid progress, the United States is also making strides in humanoid robotics. Tesla, under the leadership of Elon Musk, is developing its Optimus robot. This project, while still in its early stages, represents a significant commitment from one of America's most innovative companies. Agility Robotics, another US-based company, is set to open a robot factory in Oregon to produce its bipedal digit robot. These efforts show that the US is aware of the potential of humanoid robotics and is working to maintain its technological edge. However, the approaches of the two countries differ in notable ways. While China focuses on rapid development and mass production, the US approach appears more measured, with a greater emphasis on advanced AI integration. This difference in strategy could have significant implications for global technological leadership in the coming years. The US may be betting on developing more sophisticated AI-driven robots that could potentially leapfrog the capabilities of their Chinese counterparts. Despite the rapid progress, several challenges and concerns remain in the development and deployment of humanoid robots. The ethical considerations of widespread robot deployment are complex and multifaceted. Questions about robot rights, liability in case of accidents, and the potential for misuse need to be addressed. The socio-economic impact of large-scale robot adoption is another area of concern, with potential implications for employment patterns and income distribution. While new jobs will be created in the robotics industry, there's a risk of growing inequality if the benefits of this technology are not widely shared. Policymakers will need to consider how to ensure that the transition to a more automated economy doesn't leave large segments of the workforce behind. Technical hurdles also persist in the development of humanoid robots. While significant progress has been made, achieving human-like dexterity and adaptability in varied environments remains a challenge. Robots need to be able to handle unexpected situations and perform a wide range of tasks to be truly useful in diverse real-world situations. Ensuring the reliability and safety of these robots in unpredictable environments is crucial for their widespread adoption. Looking to the future, the humanoid robot market is projected to grow significantly. Goldman Sachs forecasts that the annual global market for humanoid robots could reach $38 billion by 2035,